And now to the actual topic of this webinar. So here is a link to the actual service. There are two main screening services there, urban and traffic infrastructure. For traffic infrastructure, there is already a webinar online. I think I didn't publish it yet, but I will. For the urban screening, we differentiate between the basic, which is really basic. You just get hazards, you overlay the exposure on it, and if you know what you're doing, you can get some idea of where the problems will be, but that's very dense. The advanced one really does some calculations and downscaling on the fly. It uses this input data. Actually, this is the input data we started with in the project. Some of it, there is some more like elevation and some data which is related to flooding. Then what we did, this is actually what ZAMK did. They calculated 23 hazard layers for the whole EU. You can see this is important. It's 12 kilometers square. So you will see nothing on urban level, but you can see changes in time. And high resolution.
And these are based on, yeah, sorry, can I just say these are based on, on a number of Eurocortex simulations. And then we've calculated for each Eurocortex simulation those indices, and then we've put together an ensemble. We provide the ensemble mean and the ensemble standard deviation for all of these indices.
Remind me a bit later to show what kind of modeling is behind it. We have it in the tool. Good, and these are the land cover layers which we calculated also from available data. They show different variables which we need for calculations, and some of them also nice for using in your report. This is also interesting. All these green spots is where we can do the calculations. It's quite a lot, and I've enlarged a couple of these green spots just to show you what it is. So for instance, this is the city of Vienna, and this is about 70 kilometers away from it. And this is about 50 kilometers. So it's quite a large area around it. There are like a dozen of smaller cities here, and for all of them, this will work. What will work? Well, we have downscaling. This is Madrid, by the way. Downscaling on 500 meter scale at the moment for two types of hazards, for several types of exposure, and for several types of impact parameters. I will show it's really simple to use. Rapid results, well, not as rapid as click and it's there, but like 15 minutes, half an hour, and well, inexpensive. You've already seen where it's possible to do it. And once this is done, then we also have the adaptation options, adaptation strategies, and the calculation of what happens if I apply adaptation strategies to my project. I must admit, this is at the moment still not as good as it should be. Again, parameterization is a big issue. Doing parameterization for all Europe is, wow. One has to do it really region by region. And twins, that's kind of additional information which is considered useful. We'll show an example or two. It's just text and pictures on like existing projects, good examples, and so on. And this is it. We are going to demonstration now. I just want to say again, this is a good prototype, but it's a prototype. It's something which came out of research project. Part of it we know has been validated. It's really working well. That part we will actually concentrate on today. Some other parts are still, yeah, I'm not so convinced that the results are ideal, but we will be working on that in the future. future we will improve them. And also what we want to do in the future is to extend this to new domains. So we are currently looking for opportunities for further financing on the research level, but also really for making this into operative tool, what we have now, to have it for certain regions. And we will be doing this very, very probably for Linz. And if you have a region which has interest, please contact us, and we would like to talk about that. So that was it, me and Claudia. And the rest of the partners, you see, we have very good partners in Italy, Spain, Austria, Germany, and Sweden. I will not go in details of that. Good. Now let's go to the actual work. I will start here by just showing you how to create a new study. There is an extra shared tutorial explaining you how to get the login. Basically, you go here and you say, I want to create a new account, and eventually you get it. I'm using my administrator account here, I believe, or maybe not, I'm not sure anymore. So let me see if I'm using my local administrative account here, and everything is as it was, which means basically that there are a little bit more things that one can see, like for instance, this maintenance, where I can see where currently we can do studies and some other information. This is all not shown to normal users, but okay. And now, how to create a study? Simple. Press the button, give it a title. And the study type, this is important. In this case, we are going for advanced screening urban infrastructure. This is important. The rest is less of a problem. One can change it later. Now, we have the study. Nothing is done yet, but we have the study. So you will not be seeing this part, but we will see just this. And this is the first step, where you get just some description, how this all works, what is going on, and what you can also do. Just a moment. Yes, I have to press once more, I'm sorry. What you can also do is change this description, so you can just completely remove it if you don't need it. There is also a possibility to replace it with something else, but at the moment the texts are not so interesting. And you can just write something about your study, because I will explain you why, so later a bit. Etc. So you can describe why you are doing this study, what is important for it. You can later give some summary on it. Why? Because in the end, this study will make a report. And this report you can print out as PDF, and you can show it to your boss, you can show it to somebody who is willing to finance it, etc. That's the whole story. When you are done with it, you already have a simple report. Second step is adding people who will work with you. So Claudia Hahn, and she is a team member, which means that she can edit a lot of things, but she cannot delete the whole study, and she cannot delete anything, I believe. So now we have 2 members here, fine. Context, very, very important part, is to choose where we want to do the study. So you choose the country, you choose the city.
Yes, and in case you don't find the city you're looking at, then this is not available for the advanced screening. So then you would need to go back and to choose or select the basic screening, and then you have at least a few features like the climate indices and information from Copernicus, just not the local hazard and local calculations that will be done on the fly for the advanced screening.
I'm choosing here Austria Linz because Claudia and I spent some time yesterday and already started one study in Linz. And this is the area which we know very well, so we will just stick to it for this demo. The other areas work as well. There is one shortcoming at the moment. I will explain it a little bit later, but this is important part. There is also a second part which is important, which is study scenarios. You have to choose which scenarios you are interested in. So I usually choose something like historic 1 year. So this is a historic 1 yearly frequency. And then in addition to this, I choose whatever I'm interested in, this.
You have 3 different periods in the future you can choose from, like from 2041 to 2070 or the end of the century. And then you can choose between different RCP scenarios as well. So whether they are...
Usually I give them better names, but this is not so important at the moment, just to show you how that looks like. I can request publication or just keep it private. I will keep this one private. Now we have defined study scenarios. You can come here anytime later. You can redefine them. It's not a big deal. You don't need to recalculate anything. Yeah, just it will be immediately available. It's just convenience for you to be able to easily switch between scenarios. This is the next part, which is to choose where we want to do the study. It's done by clicking on this toggle edit first. So when you come down here, you see toggle edit, and then suddenly this thing appears here. So I want to make a big study now. So it works up until 500 square kilometers. If I try bigger, it will tell me, no, you cannot. Yeah. So I can do something like this. Okay, this is 300 kilometers. It's fine. And save changes. While I'm at it, what I can also do is I can take a screenshot of this, include in report. And this is a study area. I don't want to write anything about it. This is a very important concept. On many places, you will find this include in report button, and it always works in the same way. And final step, the data package. So I need to choose, and in this case, I can choose only this one data package at the moment. So it's very easy. There are different data packages for different types of studies, and this one has all the data we need for these calculations. So you can read here what it is about, but it's not so important at the moment. And yeah, that's it. And now I can see everything is ready, and I can start the calculation. So calculation, trigger it. What happens now is a signal is sent to the backend, which does these calculations. I get a message, yes, this signal was sent to EMICAD, which is an operative tool of AIT, which is used mainly for quality of air calculations and emissions. and then you will see this. This will just update over time, and when it's done, it's done. Then you can go on and work with it. Now, I don't want to wait next 15 to 30 minutes, which is why we are now switching to existing study, lean screening new workflow. The first part,
you can have a look at least the hazard without waiting for the calculations.
Because, oh yes, I can, but it's the same. It's the same.
Yeah, just for the user. If while you're waiting, you can already have a look at the hazards. But
you can go to hazards, and you can actually read what this is about. Again, you can change this description when you don't need it anymore. You can look at the data. Well, this is actually quite interesting. So let's take hot days.
Hot days, yeah.
Now, this is interesting. So please explain.
Yeah, so in this, if you're under the hazard tab, and then if you go to the data, I think, yeah, that's where Dennis is just now. You have a list of all the climate indices that are available in this European data package. And if you click on one of those indexes, you see a description, kind of the metadata of the data that is provided of the climate index. So there's a definition, it shows the units, and it shows what Euroqodex simulations have been used to create the ensemble mean, which will be shown in this tool. So here for this one example, it shows the average yearly number of hot days in Europe over a yearly number, the average over the 30-year period that we have chosen. So we've said before there's a historical time period, and there are 3 future time periods that we can view. And yes, and then there are all the models listed. And this you can have a look, you can see for all the other indices as well. They're not only hot days and summer days, there are also indices for precipitation or cold periods and things like that. And then I think if you can go a little bit further up, then people see the tabs where you are. Yeah, okay. Because yeah, if you're under hazard, then you can have a look at the introduction, which explains something, at the data, that's what we've seen before, which lists all the indices, and then here's the table. And if you go to table, it shows you information about a Euroqodex simulation, and for each period, in this case here is the baseline, and event that you can choose, like a rare event, which occurs once every 20 years. You can choose an occasional event, which occurs kind of once every 5 years, or a frequent event, which would occur every yearly, kind of every year. And for this, you see that the numbers change, like the event descriptor that is here. And this is the input that is necessary for the next step, the hazard local effects calculation. And this is an event, a frequent event, which shows once every year there will be a day where 30 millimeters of rain will fall. Or if you have a look at, yeah, this is the frequent event exactly.
There is one important thing to mention here also. So this event description is not very easy to understand, but it's basically the lower this number is, the less frequent the event will be, and this is kind of the temperature which we expect in this heat wave. But what is important is that sometimes, very occasionally, actually it happened in the scenario we calculated yesterday, it will happen that for some combination you will not get these both events. When this happens, then the calculation, everything we will show further, doesn't work for that combination. So please, if you notice that something is kind of seems not to be working, missing, check this. If this is missing, then there will be no calculation done for that particular combination.
So now, there should always be 2 lines. Yeah.
Let's go to the maps. And let me see, consecutive summer days, yeah, that's nice. And consecutive summer days standard deviation.
And that is an important part as well, because here we can see the ensemble mean for this climate index and also the ensemble standard deviation. So we have a measure of the uncertainty, because as I've said before, we have different climate models, different climate runs, and for each model we've calculated the climate index, and then we've calculated the ensemble mean and ensemble standard deviation, because every model has a slight gives a slightly different result. And if you have a look at both, at the mean and the standard deviation, you also have an idea how variable the model predictions are. And and what you've seen here, maybe if you go further and if you click on the map, because like this you don't see, well, there's not much of differentiation, but if you can click on it and then you see the value of this climate index, and if you zoom out, then you see how it changed over year. Because here we have a 12 by 12 kilometer resolution, which is not very high.
Good. Now let us explain the twins ones. So it's relatively simple. You can, in this case, you can like choose the hazard. You can also choose the search radius from you. So you have to allow the map to show where you are. And then you can take a look. Oh, this is about the European heat wave. Yes, that sounds like something I really want to have in my, you can also click here to see what it is. It's the same thing. And you just say, I want it in the report. And the result of what we have just done here is then in the report chapter. You can see this was what I just made on a map, and somewhere around here will be, here it is this included information about 2003 European heat wave. And that's how it goes on every step. You make a decision what you really want to have in there. You see, this is this text which was in introduction. If I just change this description, then it will be in a report as well. That's it. It's very simple actually to use, and it's quite nice. Now I'm going really to the other study. It's the same story, and you will see here we already added a couple of this summer day maps to show you that like you can really see the difference between different scenarios. Of course, when you are in a city, it's 12 kilometers square. You will not see any city infrastructure there. It's just a blob for the whole city, or maybe 2 or 3 for a very big city. For London, maybe even 10, I don't know. But you can click on it, you can get information how it changes over time, how it changes over different scenarios. And you have seen it just before, you can have this information also on the map. Now we go to the next one, which is where the real fun begins. This is what is now being calculated here. Let me see how far we are. Oh, it's even completed. Okay, I will show you later then it really works, I hope. And now this data part shows just these 4 pieces of information. And the important thing is, so these are then calculated on the fly by AMICAD. And these calculations, you can have them in a tabular form, which is admittedly not very nice to read, but it has some advantages, like you can see what is the lowest and the highest UTC temperature in this particular scenario or in some other scenario, also runoff. And most importantly, you can just download it. So just say download. And you can then open this data. Where is it? Here. And this gives you all the information you need to use outside of this application. So if you want to use it for some external applications later, this is possible. It's very easy to get the data. And and what you see is what you get. So you can choose here different scenarios, different frequencies, different years, and then download it for that combination. This is what we use then for validation, for instance, against different models. Yeah? Now the maps, and I said we have currently a problem with flood calculations being limited only to a couple of regions. It's not a technical issue. I mean, it's an issue which is caused by our colleagues who were putting in the data, just forgetting to put a couple of parameters, and should be resolved in a couple of days. Now let's see what these maps do. So you can choose backgrounds. Personally, I don't find this very useful. You can choose also some inputs from external sources, which can be useful for some particular types of use. And here is what is really calculated. So we have a couple of parameters which are important for heat, and also one parameter which is important for flood hazard. So again, same story as usual. You can change the scenario. You will see something different here. You can also zoom in, and you see this is now already showing differences in a city. Yeah? So this is really a center of the city. Like here is a hill where nobody lives, and which is a bit higher and has trees on it.
And it's green.
So,
yeah.
So you can really, at this resolution, you can really see the city fabric. This here is industrial area and a port. And on a flooding part, you can see, of course, this is the lowest part of the city, but also it's not just a question of being it low, because this is not the fluvial, not the flood from the river, it's fluvial flood. So the highest risk will be on places which are below some kind of a hill and are lying relatively low, so that they get a lot of water.
And which are sealed, usually, where the water cannot penetrate. Yeah.
Of course, sealing is important part. Yes, that's true. Good.
And yeah, that's what you see, right? And on top, you can change the scenario. Just there you go.
I didn't make any screenshots here, but we can do it now. So let's say we take, this is a nice scenario yearly in the past. So let's take mean radiant temperature and local flood hazard. Let's include them. I will now do this really fast without writing anything, just click. Okay, save. And now let us select some extreme scenario that we really can see a big difference. It's always easier to see the difference when you have it already in your report, because otherwise, you know, you forget what was there. And it's always also interesting to see the actual numbers. So You can get here the numbers. They are, well, not extremely nice for reading, but they are pretty clear when you think about what it is. So this is which scenario? Baseline scenario, RCP85, rare. This is a grid ID, where this position is, which, well, you can see. Baseline, which means no adaptation options, time period, emission scenario, event frequency, and these are then the actual values like the MRT, UTCE. Oh, now I see that actually the one on the flood is missing. I have to tell this to the developers. Good. And yes, of course, you can include this in the report as well. Good. And then if you go to report chapter, you will see, for instance, okay, there is a really big difference between the two. This for the heat, we have validated quite a lot, and it's really pretty accurate. And this one for the flood, that got much less validation. We made checks for plausibility. It looks plausible, but I cannot put hand in fire now that this is really exact numbers. Possibly we will need to do some improvements of this parameterization of the model. Next part is the exposure. Exposure is, well, a simple thing. It's where your elements at risk are. So in a table form, you can see here I have population, roads, residential buildings, non-residential buildings. And again, you can see this is in square meters. This is in number of people in 500 times 500 meter square grid. This will, of course, vary depending on where you are, and go from 0 to something. Also, at the moment, this doesn't change with scenarios or with time. It could, but we didn't have the data. The map is, well, not very surprising. Well, actually, there is a little surprise. We have a couple of different variants how to show the population density. So it really depends on what suits you better. This is in numbers, this is in kind of from very low to very high, which, as you see, is not very appropriate for Linz, because Linz is, yeah, not a very big city and not a very dense city, so everything here ends up in low and medium. But if we do this regionally, of course, we would have different parameterization. And as for the, recenter this again, and as for the flood-related exposures, we are not showing at the moment those parameters in a table, but instead you can just choose to see all the layers which are showing what kind of
land use or different kinds of
land use we have on specific places. So you can see this is industry here, and these are
dense urban areas.
And if you go out of the city, you will find different types of houses. There are also some recreational areas here. This is green, that's grassland. So if you're interested, like to see, okay, I want to know about the transport infrastructure, then this is it, roads and railways. Again, you can make screenshots of this as usual. Twins, yeah, this is a little bit different when it's about elements at risk. So you can choose here. I want some examples which are talking me something about the population, and if you find something which is useful somehow for you, include it, if not, not. Report chapter as usual. Vulnerability is actually very simple. All we have here is explanation of how impact is calculated. So you can see I have included here one already. It depends on what you're interested in. So for instance, this is mortality. I can include it in the report. And this here is for download. It explains how in details on how mortality is calculated. So it has all the information which you may need. That's it. And now we are coming to the results section, let's say. Again, data table maps and the new one, scenario analysis. Table in this case has a lot of parameters. It's, again, I find it useful sometimes to look at maxima and minima in my region of interest, but above all for downloading. Maps. Here you can have the results. This is actually mortality. We call it number of affected persons so that nobody comes and tells us, yeah, this is really bad. It's a little bit political question, especially when you think that this mortality is kind of, imagine you have 2 times the same event today and then next year. And today 500 people die, but next year probably only 200 will die because those who were the most vulnerable just died this year. So next year there will be less people. Maybe people get used over time, etc. So it's a little bit risky to really call it mortality, but that's what it is. Excess mortality, of course. Here again, you can have all this data for a search for a single dot. So these are 2 parameters for the heat impact, and again we have also some flood-related impacts. So this is the flood damage class, and that one is how much it's supposed to cost. It's calculated by multiplying the damage class by average price for different buildings. Scenario analysis is what is new here, and this is how I use it. First, disable everything, then enable those which I like to have. And we already have adaptation here. I will ignore it for now. So, past. End of the century RCP 4.5, end of the century RCP 8.5, so worst case. Middle scenario, I mean, I could add the 2.6, but it's really not very probable. And then you have a lot of data in the table. And I can show you here already the problem with the current prototype. We decided at some point to use some indicators which we first put to numbers 1 to 5, and then we sum them all over the area of interest. And this was an error, actually. We should add 1 more decimal so that one gets some more differentiation here. This is then following us on some other aspects like these here, where seemingly there is a very little difference in indirect economic impact, whereas this is related to mortality, which is calculated in correct way. And you can see that there is a big difference in economic loss related to loss of life. Actually, this one should be approximately the same, well, maybe not that much difference, but it's really just the problem with this quantization here, which we will resolve. This is the most interesting, actually, parameter at the moment. If you look at it, baseline, okay, sorry, past, future, medium, future, worst case. And you can see here that mortality increase in the past in a rare occasion, which is once in 25 years, is already comparable to medium yearly and 5 yearly, which is occasional. And in case of the worst case scenario, we are already above it on a yearly basis. So it's really unpleasant. And then here is the calculations for flood and buildings. You can see it also in graphical form. You can include this in a report. It's not the best of all possible visualization techniques, which means that in the future we will pay more attention to improving this, but it's good enough to get an idea. Report like always. And so now let us breathe for a moment. We are going to the next step, which is what can I do about it? In this step, we have very simple thing, which is actually similar to the twins in nature. Let me remove everything for now and reload, because otherwise I will not see those which I removed. So these are the adaptation options for which we have some information, what they are applicable for, how they change local effects, so they are changing albedo, emissivity, transmissivity, etc. What kind of co-benefits I can expect from it, and the rough description, and also the costs. Yeah. So this is what I know about this adaptation option, and I can just inspect them and figure out for myself what I think may be useful for my project, and those which I believe are somehow useful for my project, I can just include in the report so that I know what this means. That's all. Then I get this information in the report. Almost all, because the twin is also reacting on what I just choose, and it will show only those pieces of information which have some of those adaptation options I just choose used in this project. So these are really on this place. What I'm showing are the projects which somebody did, which are considered good or maybe even bad practices. And yeah, then you get them in your chapter and you can read about them, and you can learn something from it. Good. So this is things which I've included somewhere here. I don't have any attached maps or techniques. So no calculation is done here, but this can be quite useful in a sense that you get an idea of what kind of adaptation options exist there and what they do. Now, this is probably a little bit misleading name, but what it does is it allows you to make this adaptation project. So when you come here for the first time, okay, let's just see, this is the one which we calculated today. So just proof of concept. Let's see if the table is here. Yes, we have some data now. At the beginning, there was no data here, so you see this graph. Now, when you come to this appraisal step for the first time, table, what you will see is that you can add adaptation project. You add it, you give it a title. You can put some information here, and then you can edit it, and you can give it a description. But above all, you can choose strategy for different types of infrastructure. And for instance, for roads, I have here the possibility to choose between rain gutters, green areas around the roads, and drainage areas. Why? Because at first we thought about letting people just choose, okay, I want this adaptation option and that adaptation option, and maybe even click on a map and say, I want it here and I don't want it there. It just turned out this is much too much work for people to do just for a screening. This is supposed to be something which you can do fast, which gives you some information, and then equipped with this information, you can go and try to do better, like really fully fledged study to ask somebody, please make me a calculation for this, what I choose here. It's very easy to use. So you have to choose one. You cannot choose two. You have to choose one of them. You select it, and now you have your strategy for roads. The same thing for other places. Here you choose for which percentage overall you want to do it, and that's it. Then we trigger calculation. So you will see nothing special here. Actually, if you go back here, you will see again that it's calculated. And it will again take half an hour or 15 minutes. So here I've done it already. I have an adaptation project which has certain strategies for well, none for vegetated, none for roads, but certain for built open spaces and certain for buildings. So we are adding agricultural parks. And if you want to know what this agricultural park is, then you can either go here and read it, or even better, you have it down here. So agricultural park for built open spaces. This is what it is. This is what it does. This is what kind of changes you can expect with it. Oh no, sorry. Okay. This is for bioswales. This is for retention basins. This is for, so this is all which is included in that adaptation strategy. And if it would be possible to do this adaptation option by adaptation option, the problem would be that you can very, very easily make a mistake and combine two adaptation options which just cannot be combined. Like I will put intensive green roofs and extensive green roofs on the same building. It just doesn't work. So here you just cannot do this kind of error because everything is pre-selected for you in what is considered a sensible way, and then you can just go on. So I've already done calculation here, and in the final step, what you get is the possibility to compare things. And I must admit, I'm not 100% happy with how that looks like at the moment. This is another area. Oh, sorry. This is another area where we will need to improve things, but okay. Oh, so forgot to say this case is now different in a sense that you have left and right. You can choose the same index, and you will see the difference between them because one of them is with adaptation options, one is without. Same thing here. It's for the hazard itself. So here you can much easier see with and without adaptation option what kind of changes to expect. And these are then different. So you can see this one doesn't have a very good scaling for this particular study. These are different parameters which you can take a look at. This is discomfort, by the way, UTC. This one is the actual mean radiant temperature, probably the most important parameter for us. And again, you can include it in the report. Of course, you can take a look at the data, like usually by clicking on this, and you get the data. Scenario analysis is exactly the same as it was before, except that now, if you are doing this step by step, now you get those which have adaptation. So you can take a look just like, okay, what is the difference between one with adaptation and the one? Actually, it's better to click it the other way around. So without adaptation and with adaptation, exactly the same scenario. And then you can take a look at how much difference this makes. So economic impact on life and increase in mortality rate. As I said, these are the best parameters we have at the moment. This is it. You can include it in a report and you are done. I admit that this is actually the worst part of the project at the moment. This really needs to be made specifically for a region, whereas the hazards, they are kind of okay, especially the heat hazards. The impact parameters really need to be modeled specifically for a region to get something which you can then really put the finger on and say, well, this is something we should really take care of. Claudia, do you want to add anything else?
No, I think that's fine. Regarding the different steps that you can see here, always if you want to have more information about what is being done in each particular step, you can go to the introduction tab. Well, yeah, for the last one there's not that much, but for most of the others, which explains you what's being done and maybe also the limitations. Yeah.
So that's it. And Andrea, do we have any questions from the public which we need to answer?
No, we have no written questions right now. Maybe we can make a not a written discussion, but by having people talk. So you can unmute yourself if you want to talk and have a question, have your say. Any comments? No questions so far, no comments. People are overwhelmed. Dennis, I can't hear you. We can't hear you.
Good. I have just unmuted myself. So final words from me. This workflow is really good. It works excellent. We are able to also make different workflows. We did like 4 or 5 different workflows here. And if you look at these different things we have, like, you know, these sub-steps with tables and maps, every time when I see something like that, this is actually JavaScript application, which can be any kind of JavaScript application. It can be from third party. We experimented with different types of things. Traffic screening has completely different application than this one, which means that if one has, for instance, in a region, if one has already some applications, they can also be included very easily in this workflow. We can make specific workflows for specific customers very, very easily. And every time, the point is that we don't need to invest a lot of work in integrating them. As long as you can see them and include the results which you see in the report, we are fine. Then you can have it in the report. I think that this is really a clever way to deal with this, because otherwise it's very, very difficult. You have to develop specifically for Verkko. In this case, you don't. If you have ready application with JavaScript, web application, we can just include it. It's very easy to do. That's one thing. Another thing is we are currently discussing with City of Linz. We will very, very probably have a project for them to produce a working tool for them. And there is also discussion in Italy, which was a little bit set back due to Corona, but we have high hopes to have then the next execution in Italy for the traffic application, which I said there is a special webinar for it. We are also have a lot of interest for making it into a operative tool, and this is something we really hope will happen in the next 1 or 2 years. And if you think that this is interesting for you, for your region, etc., please contact us and we can talk about how to involve you, maybe first as observer for our first projects and then make a project with you. And the rest is, of course, for the research. We have big ideas or where to go with this with research. And we are also going to write some research projects. Again, if you think that you have something very interesting, you want to talk with us after this webinar, there will be a questionnaire. You can just write down if you want to talk with us. We are extremely busy until the end of this month, and after that we will at the leisure go and contact these people one by one who said that they want to talk with us. We basically didn't contact anybody from previous webinars yet because we were like up to here in Bern. That's it from me. Claudia, Andrea, do you want to add anything? In that case, thank you for joining us, and please fill in our final questionnaire, and especially if you want us to contact you back. But even if you don't, we want to know how you like this, whether you think this is useful, and this is where you can give us that feedback. Thank you very much. And maybe see you tomorrow or on 15th on our next webinars.
Thank you. Bye-bye.